Hi, welcome to week 14. This is the homework solutions, not the homework preview video. So for my other class, I got a feedback that students thought me going over the homework for the solution was a little more helpful. So I'm going to try this, and I will ask you guys for your feedback, whether you like this one or the preview method better. All right, so again, these are the actual solutions to the homework problems assigned. So make sure you guys try, at least give some time thinking about the homework problems before watching the solution video. Okay, so the first problem assigned was number 7. So what is the probability of these events when randomly select a permutation of the set of 1, 2, 3, and 4? So let's go over from A. So 1 precedes 4. So we can do it two ways. We can just kind of abstractly think about the cases of when the number 1 is preceding number 4. Or I think that might be a little too abstract for now, so we can actually go ahead and count. Okay, so let's actually do that. So we have 4 spaces, and 1 needs to precede 4. So I guess our first option is when we have the 1 in the very first place. If we put 1 here, then we have 3 remaining spaces and 3 remaining numbers. So this could be, we have 3 options, 3 choices that could come here, which could be 2, 3, or 4. And out of these, 1 could be used, and let's say 4 is used here, then we have 2 choices here, okay, which could be 2 and 3. And let's say the 3 is used here, then we only have the last remaining option, which is 2. So these being independent events, what do? We multiply these numbers, so we have 6 possible solutions. All right, so that's the first case. What if we have 1 that is coming to at the second place? Okay. So we have only 2 choices here. For these two, the number 4 can either be here or here. So we have 2 options for that. All right, so let's say 4 ended up being in the third place. Then we have the remaining number, which is numbers 2 and 3. They could be either here or here. So that's another 2 choices. If 2 is here, it must be 3. Another option is if 3 is here, then 2 gets to be there. So we have another 2 solutions for 2 possibilities. So if we multiply this, we have a total of 4 outcomes. All right, and the last case we need to decide or think about is, what if 1 is coming at our third place? Okay. If this is the case, then we have no choice but to put 4 here. 4 must come at the last place, and for the remaining numbers, which are 2 and 3, if 2 comes here, then 3 can be here. If 3 comes first, 2 comes there. So we literally have just 2 options. Okay, so if we add up all of these numbers, 6 plus 4 plus 2, we have 12 possibilities. And out of 12, what's the total number possible? So we have 4 numbers, and that could be 4 factorial, which ends up being 24. So this is 12 over 24, which reduces down to 1/2. So this is the answer we got, the correct answer we got from actually counting all the possibilities. But let's think about this kind of abstractly now. Hopefully it'll make more sense. So out of all the combination of these numbers, half of the possibilities, half of the outcomes, if you take a look at those numbers, 1 will precede 4. And the other half is the other way. The other half will be 4 will be preceding 1. So to give yourself a smaller example, let's say we're looking at a set of 1 and 2. If this is the case, then the case that 1 precedes 2 is this, and the the case also that 2 precedes 1 is this. So out of two possibilities, 1 preceding 2 is 1/2 of the 1/2, and the other case, 2 preceding 1 is another 1/2. Okay, so answer for A is 1/2, and that goes likely for B, the other case. The 4 preceding 1 would be another half. So here is 1/2, and here is another 1/2. And if you want to really check, then you can go ahead and apply the same method as we just did for part A and count all the possibilities. Okay, so that was B. Let's take a look at C. So C is 4 precedes both 1 and 2. Okay, so let's actually count this one as well. So part C. So we have 4 places here. Let's say that 4 is occupying the first space. Then we have both 1 and 2 can be anywhere of these two, so we can actually have 3 choices here. And after 1 has been assigned, we have the remaining 2 choices, and the last leaves 1 choice. So we have a total cases of 6. Okay, so that was relatively easy. As long as 4 is here, any one of it can be 1, 2, and 3 can take any of these places because 4 has to precede both 1 and 2. Okay, so what if the 4 takes on the second place? Then we have 2 options. Both 1 and 2 must be here. So we have either case of where it's 4, 1, 2, or 2 and 1. And this place is kind of settled. It has to come, the number 3 has to come here. All right, so if I count up these number of ways, I get 2. And the other cases, this wouldn't work because both 1 and 2 needs to come after 4, but I don't have a space for that. Okay, so this does not exist. So the total number of ways is 8 divided by the total case is 4 factorial, which we have 24. So the answer for C is 1/3. All right, let's go ahead and think about D. So D is a case where 4 needs to precede all the numbers 1, 2, and 3. So it can only be on the first place. And it doesn't really matter what the orders are for the remaining numbers of 1, 2, and 3. Okay, so I guess we have 3 choices here in this place, and one number is used up. We have 2 choices, and we have the last number remaining, so we have 6. So for this, we have 6 cases out of 24, which will be 1/4. So the answer for D would be 1/4. And finally, for part E, I will actually leave this one to you guys. I'll tell you the answer. The answer for part E should be 1/4 again. Okay. So 4 needs to 4 precedes 3 and 2 precedes 1. You can count the number of ways, and there should be only 6 cases that satisfies this. And so 6 divided by 24. The final answer for that should be 1/4. Alright, so let's go ahead and cover the next problem, which is number 8. So number 8 is what's the probability of these events when randomly select a permutation of 1 and the number goes all the way up to n, when n is a number greater than 4. Okay, so I think we can answer part A and B pretty easily, continuing on from the previous problem. And so the answers for part A and B would be 1/2. There will be exactly half cases where 1 precedes 2, and the other half cases where the number 2 precedes 1. All right, so letter C, 1 immediately precedes 2. So this is a pretty interesting case where 1 and 2, these numbers have to kind of travel together. Okay, so it doesn't really matter which part of the formulation they exist, but they just need to always go together. So let's say n is 4, okay, then we have, let's say n is 4, then we have the set contains 1, 2, 3, and 4. So out of 4 spaces, 1, 2, 3, and 4, let's say if we put 1 and 2 here, they're kind of bound together. If that's the case, then how many choices do we have here? 1 and 2 is used, so we have 2 other choices. It could be either 3 or 4, and the last remaining choice. So, and it could 1 and 2 can be here, and also here. So this kind of shows that if we count 1 and 2 as if we consider that as one number, then our total number of choices is just 3 factorial, which would be 6. So keeping this in mind, our total number of choices for if we bound or if we connect 1 and 2 together, if we think of that as just one number, then out of n numbers, we would have the total number of n minus 1. Okay? And n minus 1 factorial would be the number of the possible alignments, and the total number of all the arrangements is n factorial. Just like in this, when our n was 4, then the probability of 1 and 2 arranged together, then this was 3 factorial divided by 4 factorial. Okay, so this is n times n minus 1 times n minus 2, and it goes all the way down to 1. And the numerator is n minus 1, n minus 2, and it goes all the way down to 1 as well. So all of this part would be canceled out, so we will be left with 1 over n. So this is our answer for C. C is 1 immediately precedes 2. The probability of that happening is 1 over n. Okay, so part D, n precedes 1 and n minus 1 precedes 2. So let's think about this kind of separately. What's the case that n precedes 1? That would be, as we've seen from the previous problems as well as part A and B here, this case would be 1/2. The probability of n preceding 1 is 1/2. And what about this? The probability of n minus 1, whatever that number is, precedes 2, that's another probability of 1/2. So these numbers, notice how all of these numbers are different, 1, 2, and if n is 4, then this would be 4, and n minus 1 would be 3. And because all of these numbers are different, these will be independent events. They will not be depending on each other. Which means, for independent events, we can multiply this, so the answer for D would be 1 over 4. Alright, and last part, for E, I think probably the easiest way of thinking about this is just come up with a number. Let's assume that n equals to 3. Okay? So if n is 3, then we have 3 spaces. Okay? So 3 needs to precede 1 and 2. So this would be 1, 2. Or our second option is 3, 2, 1. So we only have 2 cases, if you count them, and 3 factorial. So this would be 2 over 6, which would get us to 1/3. So this is our answer for E. and